Hey, welcome to the Explainer. Today, we're going to get our hands dirty and build one of the most fundamental tools in any programmer's toolkit, the queue. Seriously, whether you're scheduling tasks or handling data streams, mastering the queue is an absolute must-have skill. Okay, let's dive right in. So here's our game plan. We'll start with the core concept, then we'll build our first simple version and immediately see why it's got a critical flaw. From there, we'll uncover the elegant fix, check out some super-powered variations, and finally, see how queues are used out in the real world. Think of this as your complete builder's guide. All right, let's start at the very beginning. Everything we're about to build today is based on one single, really intuitive rule. If you get this one rule, I promise you, you've already understood 90% of what a queue is all about. And here it is. This is the golden rule. FIFO. First in, first out. It's exactly what it sounds like. The first person to get in line is the first person to get served. That's it. This single principle governs every single thing a queue does. And the cool thing is, you already get this. You see it everywhere. It's the line at the coffee shop. It's the list of documents waiting to go to the printer. It's even how your computer's CPU decides which job to work on next. It is a beautifully simple and, frankly, a very fair system for managing order. So how do we actually interact with this line? Well, we've got 4 basic actions. We can enqueue an item, which just means adding it to the back of the line. We can dequeue, which means serving the person at the front. We can take a peek at the front to see who's next without actually removing them. And of course, we can check if the line is empty. Simple, right? Okay, theory is great, but let's actually build this thing. Our first attempt is going to be with a tool we all know, a simple array. But as we're about to find out, this very straightforward approach has a hidden and pretty inefficient flaw. So, here it is, the big problem. When we dequeue an item, we're leaving an empty slot at the front of our array. But a simple array can't just reuse that space. So our queue keeps eating up new memory from the back while leaving this growing trail of useless empty space behind it. It's basically a memory leak built right into our design. It's just incredibly inefficient. And this brings us to the elegant fix. Instead of a straight line that just hits a dead end, what if we could connect the end of the line back to the beginning? This is the brilliant idea behind what we call the circular queue. Now check this out. It's so cool how a tiny change in code can lead to a massive improvement. On the left, our simple queue just keeps adding 1 to the rear pointer. But on the right, the circular queue uses the modulo operator. That little % symbol? That's the magic trick. It allows the rear pointer to wrap around to the start of the array once it hits the end, which lets us reuse all that empty space. It's a perfect example of how a smart algorithm can make all the difference. And the result of that little trick? Pure speed. All our core operations now take what's called O1, or constant time. Just think of it like a vending machine. It takes the same amount of time to get your snack whether the machine is totally full or nearly empty. It doesn't matter if our queue has 10 items or 10 million. Adding or removing an item is always just as fast. That is some incredible efficiency. Okay, so we've built ourselves a solid, really efficient queue. But what if we need more? Now we get to explore some specialized versions that come with some serious superpowers. So the first superpower is the priority queue. And it does something pretty radical. It completely breaks our golden FIFO rule. With a priority queue, it doesn't matter when you arrived, all that matters is how important you are. The item with the highest priority, well, it always gets to cut right to the front of the line. And why on earth would we want that? Well, because some of the most important algorithms in all of computer science absolutely depend on it. Finding the shortest route on Google Maps, guiding an AI through a complex problem, or even a CPU deciding which critical task it needs to run next, all of these rely on the power of the priority queue. So how does it do this so fast? Well, under the hood, a priority queue is usually built using this special tree-like structure called a heap. It's designed to always keep the most important item right at the top, ready to go instantly. Now, by default, that's what's called a max heap, where the biggest number gets top priority. But you can easily flip it to a min heap, where the smallest value is the one that matters most. And our other super-powered variant is the dequeue, which stands for double-ended queue. Just think of this one as the ultimate in flexibility. It's a line where you can add or remove people from either the front or the back. It gives you maximum control over both ends of the line. Okay, So we've got the theory, we've got the special versions. Now let's see how professional developers actually use these tools in real-world code and in some really powerful algorithms. And here's the good news. You almost never have to build these from scratch every time you need one. Languages like C++ provide these battle-tested, highly optimized versions right in their standard libraries. With a simple #includeQueue, you get a professional-grade tool ready to go. And one of the most famous algorithms powered by a queue is something called breadth-first search, or BFS. Anytime you need to explore a huge network, like a social network or the entire web, level by level, the queue is the engine that makes that possible. It just systematically and fairly keeps track of every single place you need to go next. Wow, okay, we have covered a lot of ground. So let's bring it all together in our builder's summary. These are the key blueprints you need to remember and the pro tips to help you avoid some really common mistakes. All right, here are 3 classic pitfalls. First, totally forgetting about that circular logic and ending up right back at our original wasted space problem. Second, and this is an easy one to do, just mixing up which end is the front and which is the rear. And third, reaching for a queue when the problem actually needs a stack, which is its total opposite. Last in, first out. So when is a queue the absolute perfect tool? Well, you should reach for it whenever the order of arrival is critical. If you're scheduling tasks, managing resources, or processing a stream of data where the sequence really matters, the queue is going to be your best friend. And here it is, the final blueprint. Let's do a rapid-fire recap. A queue is all about FIFO. The circular queue is the smart way to avoid wasted space. The priority queue uses a heap to handle things based on importance, and the standard template library makes using all of them super easy. We've gone from the basic idea all the way to a pro-level implementation. You now have a powerful new tool in your mental toolkit, and you don't just understand what it is, but why it's designed the way it is. So I guess the only question left is, what problem are you going to solve first?